A spacecraft from another solar system invades the night sky. But this is not our sky. And we are the invaders. The search for alien life has begun.
We think that other worlds, perhaps other Earths, if you will, exist. We know of hundreds of other planetary systems right now, and that may be the tip of the iceberg.
It isn't conceivable, really, that there would not be life. Is it intelligent? I don't know. That's a whole other issue.
Within a few decades, unmanned probes equipped with artificial intelligence may find life on planets beyond our solar system.
2014, that's the magic year. That's the magic year where the terrestrial planet finder goes up into orbit, and its explicit mission is to find evidence of up to perhaps 500 Earth-like planets orbiting other star systems.
There is no reason not to think that on some of them, somewhere, you would find multicellular organisms like ourselves.
The life we have on Earth must have spontaneously generated itself. It must therefore be possible for life to be generated spontaneously elsewhere in the universe.
We now take a simulated journey, scientifically verified by leading experts, to a planet called Darwin 4. The life it supports tests the limits of technology and the intellects of the greatest minds of our generation. Because here on Darwin, life is truly full of surprises. An interstellar spacecraft named von Braun leaves Earth orbit for a planet some 6.5 light years away. Are we ready to confront the technical challenges of a mission that will take decades to complete? To find out, a team of top scientists, engineers, and artists create a virtual mission to Darwin 4, fourth planet in a binary system called Darwin.
It seemed utterly important to me that the foundation to create a world was to make sure that the world was acceptable to the science community.
Then we put together a team of scientists to have a look at that concept and to make sure that the laws of physics and chemistry were all represented in that model.
Today, we search for planets like Earth through telescopes. The Darwin 4 mission simulates the next giant step, the unmanned quest to find life beyond our solar system. The von Braun is roughly the size of a nuclear attack submarine and travels at 37,000 miles per second, 20% the speed of light.
According to Einstein, there's an ultimate speed limit in the universe. Mother Nature is like a cop that says you cannot break the light barrier. Now, the nearest star is 4 light years away, and Darwin, traveling at 20% the speed of light, will take 42 years to make that journey.
The metal composite nose shield that protects the ship is cratered by collisions with space debris accumulated during the 42-year journey to Darwin 4. The planet orbits the larger sun of a binary solar system in a zone just close enough to its own star for comfort. A sweet spot astronomers call the Goldilocks zone.
Not too close and not too far away, but just at the right distance that the planet can support liquid water on its surface.
The von Braun's first priority is to call home. A digital message will be sent through a laser beam, but the limits of time and space impose a roaming charge for long distance. Even at the speed of light, von Braun's transmissions to Earth take 6.5 years, making it impractical for engineers to correct problems. So von Braun and its probes will have to think on their own. The first phase of the mission is to deploy the Darwin Reconnaissance Orbiter, or DRO.
It's going to spend months monitoring weather, looking for geology, looking for signs of life.
It's going to map the entire planet, and it's going to rotate around the planet, and it's going to give us some detail on the topography.
We learned a little bit about the planet via the space-based telescopes that were around our own Earth, but now that we're actually there, we're going to look down and confirm that our guesses were correct.
So that when we put these probes down, which can only explore a small fraction of the planet, we get the most out of it.
Images surge through the DRO's camera lens. Infrared, radar, and visible light pictures reveal an equatorial mountain range and vast plains swirling with weather systems. Darwin 4 has no oceans, just a small blue sea. Von Braun's computers sift through thousands of destinations before selecting the one landing site with the most to offer. The Von Braun launches a probe about the size of a dump truck named Balboa, after the famous explorer. Balboa enters Darwin's airspace as our first ambassador to a pristine alien planet. The first contact between Earth and Darwin literally falls to pieces. But the planners of the Darwin mission have prepared for just such a scenario. The Von Braun vehicle carries 2 additional probes. Probe Leonardo da Vinci is nicknamed Leo. Leo is followed by a twin probe, the Isaac Newton, aka Ike. The probes enter the atmosphere just like the space shuttles do on Earth. The final approach is a lazy S pattern to burn off excess speed before landing. Temperatures on the surface, 70 degrees Fahrenheit. Leo is first to land and emerge from his vehicle. Leo's bird-like head is crammed with sensors. Driven by protocols embedded in his software, Leo confirms that Ike's landing is on track and sends a status report to the Von Braun. The news that Leo and Ike have landed is beamed to Earth. Perhaps it's fitting that scientists who were babies when the Von Braun left Earth now announce the birth of interstellar space travel.
Watching these probes from back on Earth would be much like sitting in the back of an auditorium watching your child at a spelling bee where you know the answer and you're sitting there hoping that they're going to make the right decision and come forth with the right answer, but also knowing that you can't do a thing to help them at this moment.
Darwin 4 has a denser atmosphere than the Earth's, and the probes would have been designed to cope with that. Now, we would have known that the atmosphere was in fact denser before we got there. The way we would have known that is by looking at the spectrum of this planet and looking at the signature from oxygen in the planet. That oxygen signature would have been so broad, we would have known there was much more oxygen there in that atmosphere than we have on Earth.
Well, today, our awareness of the universe has expanded, exponentially, really. we've gotten smart. We've learned, we've done our homework. The first wave of space telescopes showed us one thing. Earth-based telescopes showed us another. Physics, computers, mathematics has come together in a beautiful confluence that has allowed us to recognize what before was unmeasurable.